afternoon. So yeah, I'll talk a little bit about digital integration, standardizing, event data collection, and management with the being developed TM-Form AI data model. So the very first thing that we need to kind of think about is what is the challenges that's involved in digital integrating event data? Because we talk a lot about, well, we would like to apply this AI data model, or we'd like to be able to produce these insights, et cetera, et cetera. But we have to remember that the first thing that anything starts with is the data itself. Without data, you cannot do. And therefore, it is equally important to not just continuously look upon how we standardize, as the previous discussion was, just the models, or even looking at as to how we can distribute or standardize the models across, but equally look at standardizing how we actually collect and classify data, structure data, as well as the attributes attributes, KPIs, etc., is all in a standard fashion that enables us to very, very quickly produce the insights or run the AI data models on top of. So why is standardization of event data collection management important and a prerequisite to digital integration? I'll look at something I call the 4 steps of digital integration and a couple of use case examples where this has been taken into account and being used in today's deployments. So why is digital integration so important? Just before I jump there, I just want to make sure that there's a term that I use, and I just want to make sure that the term is equally understood. So I talk about event data. When I talk about event data, this is specifically data that's generated as per a process, or per a network, or per a IoT service. So it's the actual events that is produced as part of that particular, let's say, customer engagement process. So it is essential that we talk about all of these data points or attributes that is collected associated with those events, and I'll be using this term throughout the presentation just so that it's clear in regards to why I use the term event data than just data in itself. So last year, we did TM-Form did a survey, a digital transformation tracker survey. And they asked a very interesting question. The question was, when it comes to aligning organization culture for digital transformation, there's a number of challenges specific to generating and using different data sets. Please rank the following data challenges in order of importance. So I took the result of that, and I think this is a great place to start. Because again, I think a lot of us thinks that the challenge is applying the rate data model, et cetera, but the number one thing that came out of this survey was the ability to get the required data. So as I said from the beginning, if we don't have the data, we cannot do. So I thought this is an interesting conclusion of that actually, even if we talk about all of these wonderful things that we want to do in regards to digitizing our processes or introducing new services, we are actually still dealing with the foundation of that, which is the data itself for us to be able to actually achieve the objective. So that's number one. Number 2 is data quality. So even if it is that we get the data, we actually deal with the fact that the data we get in itself does not carry the quality necessary to produce the results we're looking for. So you can see that even before we started our digital transformation journey, the basis of which is the data that we accumulate, we're already at a significant disadvantage. So how do we overcome this challenge that seems to be dictating the ability for us to succeed? As Nick said last year in this event at his keynote, is 70% of digital transformation projects fails. I think one of the major contributing factor, based upon that survey as well, is the fact that we really want to do this. We really want to digitize our processes. We really want to do these amazing AI data model insights, etc. But we have a fundamental issue that we need to solve first before we even get to realize the dream of becoming a digital operator. So an ability to analyze the data, ability to model the required organization, and ensure how data can address organization. So at least we know data can address the challenge. So that in itself is a good news. Okay, so now that we have that approach, what I also did last year is together with TM Forum, we did a TM Forum Quick Insight report. And we talked about what we call building a data lake to drive digital transformation. And as part of this report, we looked at some different aspects of it, coming from a variety of different operators as well that was part of this report. And we looked at set of strategy, clean and curated data, collaboration, standard approach, etc. But I wanted to highlight one particular aspect of this report, which really sets the rest of my presentation, which is, so Matt, which is a director of network performance analytics at Verizon, made this particular quote in this report. What he said was that every vendor, when they provide that data to you from their equipment, describes things completely different. It's completely different terminology. By the end of the day, interface stats are interface stats. So he goes on to say there's a whole bunch of work that has to be done now to make the data usable. He actually goes on and talks about lasagna here. But the point is what he's trying to say that he has the objectives set forward in regards to digital transformation, and he wants to be able to take his data. But he spends more time on just dealing with standard aspects of terminology. And I'll give you a real example of that in a second. So with this in mind, I came up with this idea of the 4 digital integration step that has to be in place first before you even start on your implementation of AI data models or whatever it is, the downstream system that you're trying to introduce, because you need that data to be ready. You need that data to be able to achieve the objective that you set forth. So the first thing is all about advanced data classification and standardization. That goes back to what we just talked about, as was mentioned by Verizon, which is it's not even classified the same. So I'll give you a small history lesson, if you like, in the context of when I was in university, I had a teacher. And this teacher constantly made this point to his students, which was, he said, so I'm sure you've heard this as well, is that he said, so if you came in with the result, you're presenting the result to the class, and you would say the result is 10, he would always say 10 bananas, 10 oranges, etc. Because to him, the answer was never an answer unless the classification of what you were saying or talking about was evident. Because 10 in itself is not nothing. However, 10 bananas, now you know that it's fruits and you know what particular fruit you're referring to. So it has to start with us as an industry agreeing on a standard set of classification of data across vendors as an industry. Because again, as an example of that, as what Matt just talked about, is if it is vendor 1, does implement, I use fruits as an example, but does classify their data as fruits, but they happen to classify their type of fruit as bananas versus oranges, when you then use that data set to be able to produce your results, you think you are looking at bananas. In reality, you're looking at oranges, and surprise, surprise, the result that you were expecting to get is not what you get. And therefore, many times when we look at AI data models that is being used on a predefined standard data set, they produce wonderful results. But once we start to use it across a multitude of different data sets which is not classified correctly, we get undesirable results. So it has to start with event data classification standardization. The next one is event data collection distribution. I'll get back to that one. And then event data lifecycle management. So obviously we need to make sure that we understand how we manage our data throughout the lifecycle to ensure that such data is available long enough. What is the historical data sets that we need to keep? How can we purge data, et cetera? So there's a process associated with that. And also event data-driven decision making, which I'll also talk a little bit more in detail. So let me talk a little bit more about event data collection as distribution as an example of a real-time deployment that was done at an operator. So this particular Asian telco had a significant amount of back-end systems. So it was storage systems that was built either as vendors and or in-house. They had account balance system, they had a CRM system, they even had a significant amount of in-house applications, various customer systems. Their objective that they wanted to actually, and they wanted to do a digitization of process. And the process they wanted to digitize was actually self-service, the self-service portal. But the biggest problem they had, as I talked about, is the fact that at the onset, they were dealing with so many different systems that needed to be involved to be able to fulfill the aspect of self-serve. So they had to deal with the aspect of integrating all of these different systems together, even if they themselves individually were structured differently, spoke different languages, and all the aspects of that. So what we did with them in the context of this was to look at standardize, so again, standardization and classification, making sure the definitions were the same across, and then use our intelligence in the middle to be able to make sure that we could collect it and put it into a structure that enabled to actually serve that. So this is just one example of how that first step, or the second step, as part of my 4-step saw. But let me spend a little bit more time on event data-driven decision making. Because at the end of the day, of course, we want to make decisions based upon what the data tells us. This is what we started with. That's what we wanted, right? So, of course, number 4 in the sense of priority is what we wanted, but we cannot forget 1, 2, and 3 as talked about. But even in the context of event data decision making, how do we ensure that the decisions that we make from the data is actually the decisions that we want? So we specifically need a telecommunications-specific data warehouse model aligned to TM's forum SID that establishes a level analysis to deliver business value. So in a predefined set of KPIs derived from this event data that we have collected. What we're really talking about, and based upon the analytics big data repository as a base for which we build upon. So what we're really suggesting is the work that is ongoing within the TM frame, which is the AI data model. But it's the AI data model extended. So it starts with ABDR, because obviously that is a great place to start. However, the ABDR is a set of attributes. So again, important, we need to make sure we standardize our attributes and make sure we have a standard definition. But what we do need to do to be able to realize all these various AI use cases is that we build upon that into an extended AI data model that takes into consideration not only the base level of attributes, but also the enhanced attributes that we need, the KPIs we need, and also AI profiles that is required. So let me talk a little bit more about how that is. As part of a catalyst, again, collaboration is essential, we try to look upon this, all the various companies that was involved, to look at if it is that we have an AI data model that needs to achieve this objective, as I talked about here, in regards to digital integration, what does that AI data model need to be as a base for it to be able to realize a use case, in this case, digital twin, which as a catalyst that we're doing up on 3rd floor. So in case you're not aware, a digital twin is a virtual representation of a real-world entity, a system, which acts as a mirror to that to be able to simulate, predict, forecast, and possibly control the real-world entity as applicable. Very quick example. So if you are to, for instance, make an augmentation to your network, or an augmentation to your process, or augmentation to your customer engagement, what this enables you to do is not only to be able to look at the individual twin and run simulation and forecast because it now is a mimic of the real person. But what it also does is that it enables you to actually interact between the different twins to give you the actual desired recommended action and what-if analysis with all the aspects of the different possible dependencies that exist in making the right informed decision. So with that in mind, So this is the AI data model that we came up with as part of the Catalyst. So digital twin forecasting and simulation. And it consists of the attributes coming from the model that we talked about earlier, KPIs, which is calculated as the attributes are ingested. Forecast KPIs is calculated in addition to the KPI, the base KPIs. AR profiles, which is a subset of attributes and KPIs put into a standard set, and also recommended actions. So with that in mind, here you go. So with that in mind, the example I'm going to give, and you can see more of this example at the twin, digital twin stand, but here is a network twin. This particular network twin is going to do a prediction of quality of service to be able to see that preventive maintenance in the context of making sure that if things are to come and affect the network quality, let's say quality of assurance, you want to be able to then do a simulation to say, okay, in the next 10, 15 minutes, next day, next year, whatever, when is it that we're going to start having problems that we need to address? None of that is necessarily different than from what is done today in many operating installation where we do simulation on the network side. Where things start to be interesting is that based upon that particular simulation that we have done by using the AI data model, first of all, we make sure that the attributes and KPIs that we use as a basis for doing that simulation is the right data set, right? Is the right attributes, such as so we get a right outcome. But when we then do the forecast KPI calculation, that particular KPI is then fed back to the twin, and the recommended actions that is necessary is also shared in regards to what is the most appropriate action to be taken. But what we've also then learned as part of this Catalyst is that sharing such simulated results with other twins is where the digital twins technology and using that base model really comes into play. Why? Well, if I am to do a prediction on the network side, and this particular prediction is about quality of service degradation, I in itself, on the network side, with my simulation, can make an action, a recommended action. One could be augment the network, install more capacity, whatever. But in itself, one recommendation could be, let's do an upgrade. Let's upgrade the network so that, and the upgrade recommendation is 1 to 3 a.m. on Thursday. But by sharing that simulated output to the customer twin now knows about the customers and is able to map to the customers that's going to be affected by this upgrade, and will be able to then communicate back to the network twin as an example wherein it says, don't upgrade on Thursday from 1 to 3 because all of the customers that you are going to affect is more active from 1 to 3 a.m., but less active from 5 to 6. So we recommend that you should go ahead and do your upgrade on 5 to 6 rather than 1 to 3. So by having this communication between the various twins, you're able to then get the benefit of having a more holistic view of your entirety of your organization and processes, which is all based upon the aspect of the AI data model as explained. So, not sure that was supposed to be this last slide, but it's supposed to say thank you. But that was what I had to say, and I'm more than interested in taking any questions you have about what I talked about here.
Thank you very much, Claus, for that. Hello. Thank you, Claus, for that great presentation. I've been told that we're running behind schedule.
Okay.
So your questions will be taken offline.
Okay, no problem.
The instructions from the top.
That's fine, no problem, no problem.
Can we have a round of applause, please, for Claus, who's trying to standardize